All right, here we go, section 11.8. Two very specific formulas called heroes and brahmagupta. Yes, what fun to say such large words. Let's first of all work on heroes. Sometimes it's referred to Heron's formula as well. I forget who this hero was. Area of a triangle. Okay, kids? New formula for calculating the area of a triangle. It is not as convenient or as slick as our old one, but sometimes it's very useful. Notice, it is an extremely long square root. Yeah? So get that in your notes. S. What is this S you speak of, Mr. Larson? Why are we subtracting A, B, and C from S and multiplying all those together? Well, I'm not going to go through the proof. It's kind of a complex. I've been through it once in my life, a long time ago, and I'm not going to drag you there. It's okay. Rest easy. I will show you how it works. First of all, semi-perimeter. Well, you know the perimeter is the distance around. The semi is a vehicle with 16 tires on it. Just kidding. It's just half a perimeter. Yeah? So S is equal to 1/2 of P. P being the perimeter. All right? Half of Perry. All right. So given a triangle, any triangle, it doesn't need to be right? Kind of sweet. Don't have to have perpendicular sides. Nothing. All you need is the three sides. So lowercase, notice, ABC. So there's the perimeter, ABC. And then the S is half of that. And so to find the semi-perimeter, then we take and multiply. Again, side times side minus A, side minus B, side minus C. So let's practice that now with the sides 3, 6, and 7. Job 1, what is S? Add those numbers up mentally, 3, 6, and 7. Hopefully you get 16. We divide 16 by 2. So our semi-perimeter is 8. So I'm going to take 8. And now I have to subtract each of my three sides from 8. 8 minus 7, 1. 8 minus 6, 2. 8 minus 3, 5. We multiply those together. 8 times 1 times 2 times 5. Actually, I'm multiplying in reverse. It's a little bit more convenient. I think we get 80. Yeah? And the square root of 80 simplifies out to 4√5. It's really close to 9 square units. 3, 6, and 7. All right, kind of cool. No perpendicular dimensions necessary. Yay, hero. Way to go. Notice I refrained from any bad jokes. Brahmagupta. Well, I got to say that a few times every day. Well, this applies to the formula of areas of quadrilaterals. Okay, so it works with four-sided figures. Again, we don't need perpendicular sides or, that nonsense. But it does need to be a cyclic quadrilateral, meaning a circle has to circumscribe it, just like the one I drew. All right? So a quadrilateral that's inscribed inside of a circle. Again, notice it's very similar to what we just did. And yes, you guessed it, these two things are related. These formulas, Brahmaguptas and heroes. Brahmagupta, you could probably guess is, yawning, somebody from India. So again, it uses the semi-perimeter and the four sides. So take all the four sides, add them up, divide by 2. Yeah? Subtract from each of them. Notice it's slightly different. There's no just plain S. It's S minus each of the four sides. Okay. All right, so again, another example. 7 plus 9 is 16. Plus 6, 22, 24. So if I take 24 and divide it by 2, that's how I got the 12. Now I'm going to go through again, subtract all four sides from 12. 12 minus 2, 10. so on and so forth. 12 minus 6 is 6. 12 minus 9, I think, is 3. So there it is, 10, 5, 6, 3. I think I got them all. All right. Well, I think I get 900 there. Check it out. Is that true? Well, the square root of 900 is 30 units squared. So there's my area. Okay. Voila. That's it. That's all she wrote. That's chapter 8. Closing up with a couple fancy formulas. There are more formulas for other areas of shapes. We're not done. This isn't the end of the story, but for us in honors geometry, yes, we now close the book on two-dimensional formulas, and next chapter is three-dimensionals. Hold on to your seats, kids, as we fly into this last chapter.